Now let us start to dive down into the subcomponent of a processor. Okay, subcomponent of a processor, and the most important of them is arithmetic and logic unit. Why is it most important? Because it provides a fundamental operation of any computing system. Any software program you have seen or you have written are nothing but a sequence of arithmetic or logic operations. Okay, be it like a stunning gaming application, is a Facebook, Google, any other, Twitter, that kind of huge software system. If you think of, ultimately it boils down at this processor level as a series of arithmetic and logic operation. Okay, and the interesting part is that fundamentally there is no arithmetic operation done at the processor level. All is done is some logic operation. We'll be clear on this latter section of the semester, but just keep that thought in mind. There is nothing fundamental arithmetic operation. There is no fundamental arithmetic operation even inside a computing system. It's all logic operation. Okay, but even then, let's call it an arithmetic and logic unit because that unit provides you fundamental basic arithmetic operations and logic operations. Okay, so this ALU is a system, again as I said, provides the fundamental functionality of a computer. And since we are software people, let's try to think this thing as from the software perspective a little bit. Okay, then we'll map it to hardware. So you have used a lot of APIs, right, in your previous classes. Like, I'm pretty sure, especially who dealt with Java, that kind of language, or Python even, they have these libraries and APIs. So think this component as an API, software API. Okay, so let's say there is an API which has some footprint like name ALU. It returns a result. Okay, it returns a result, and you are passing two operands, operand 1 and operand 2, and also passing the specification of operation, like is it a addition operation, subtraction operation. They are all encoded in kind of a number, like maybe 0 is addition, 1 is subtraction, as in the operation field. Okay, so this is a software API, C API, and this is by the way in the C language, so you don't need to be worried about if you don't know C, that's fine. They are all similar. Java, C, all this high level language are pretty looks very similar to each other. Okay, so this is an API definition, and as a user you don't know what is inside. Okay, what you could do is that basically in your application program you call this function. Okay, you pass operand 1, operand 2, operand, and an operation definition, and you get a result back. Okay, so whoever implemented this piece of API, maybe this is the implementation part. Okay, which again, don't be bothered about this C style implementation. I'll just explain a little bit. So this is a switch case statement. It tests what my operation is, like maybe 20 is my addition, so I compute the result by OP1 plus OP2 and break, and then subtraction, etc., then logical OR, logical NOR, etc., etc. So this this is the inside my implementation of the API. So most of the time when you use a library, you don't even bother about to think what is inside the library, because you don't need to. You are the user of that API, you just call that function, right? But when you are actually writing a library for your user, then you kind of think about what would be the implementation inside that API. So similarly, in the hardware world, as a API definition, we do something like an interface diagram or a schematic diagram. Like if I say schematic diagram of ALU or interface diagram of ALU, what I mean is basically this kind of diagram. Okay, we'll simplify this diagram, no doubt. Okay, so what it does, like it draws a box which is kind of a black box to the user. User doesn't know what is inside, and there are inputs. operand 1, operand 2, and operation, and user expects a result back from the ALU. So this is an interface diagram, or maybe sometimes we call it also a schematic diagram of an ALU. Okay, so this is kind of, you're defining a software API like this. In the hardware side, you're defining like a diagram, because hardware people loves to draw. Okay, so and you guys also need to practice a lot to draw a schematic diagrams. So this is a black box. We don't know what is inside. What is the implementation? We don't know. We'll see later. So as a computer architecture, ALU is very represented with a very special object shape. Okay, so you can either make a box with a name ALU, or you can draw this specific diagram and everyone in the world knows this is ALU. Okay, and there are certain things like drawing these kind of fat arrows are problematic and time consuming. What we do is basically arrows, and to make and signal multi-bit. For example, here my operation code is 6-bit, we are saying, and here it is operand 1 and operand 2 are 32-bit, and ALU is a 32-bit. So to denote that, we'll be putting a slash into this arrow and mark its bit width. So this representation always imply that I have 32-bit of signals bunched together as a bus. Okay, 32-bit of signal. If you don't have it, slash or the number, slash and the number, then it denotes this 1-bit signal in the schematic diagram. Okay, so this is how to get we can draw an interface diagram of an ALU, and we'll see that there are more fundamental like components like a memory and the controller and so on and so forth. We'll draw their little bit IO diagram, interface diagrams, or schematic diagram, whatever you want to call it. We'll see that. Okay, but bottom line is that ALU is a very special component in the computer hardware. It has been given a very specific symbol, schematic symbol to draw. Okay, so that's the one bottom line. Other bottom line, how to draw a signal, one signal, just one arrow, one signal. If it is a multi-bit signal, then you basically cross that arrow and write its number of bits. Okay, so I think that's all for lecture 1. And if you have any questions, comments, please let me know.